This example comes out of section 2.3, Sum and Difference Rules. This example is one that students have a lot of trouble with. I do it in class as an example, like I am here. There's at least one in your book or two that are like this, and then somewhere down the line on a quiz or a test I've put something like this. And inevitably I get asked over and over and over how to do it. So it must be something that I'm doing wrong, or just a very complicated question. We're asked to find the equation of both lines that pass through the point 2,9 and are tangent to this parabola here. Now, the parabola, without getting into too much detail of exactly what it looks like, goes through 0, 0 and 2, 0, so it's a parabola and it faces down, something like this. Now the point 2,9, it's important to note, is not on there. The point 2,9, point P, is way over here somewhere. If you put 2 into that equation, you definitely don't get 9, you get 0. So what we're looking for is an equation of a line that does this from that point, touches the parabola and is tangent to it, and an equation of a line that does this and is tangent to it somewhere else. And that's why there are two of them, both lines that pass through that point. It basically comes down to understanding what slope is. Any point on this curve is going to have the coordinates x, y, or maybe even better, x, 2x minus x squared, just because that's the equation, y equals 2x minus x squared. So the slope from P to that point, slope is m, which is rise over run, is going to be 9, so change in y over change in x, so 9 minus y over 2 minus x, or if you prefer 9 minus 2x minus x squared over 2 minus x is equal to the slope of any line that goes through 2,9 and any point on this graph. Another expression for any slope that's tangent to this graph is that if I take the derivative of the function, if I said that y equals 2x minus x squared, the derivative is relatively simple. It's 2 minus 2x. That's the slope of any line that's tangent to this parabola. Now I want both. I want something that's tangent to this parabola but is also going through the point 2,9. So if I make these two equations equal to each other, 2 minus x, I have something that I can now solve. And it takes a bit of work to solve it, but I'll get some answers for x. It turns out to be a quadratic thing that I need to solve. So I'll do a little bit of the algebra here. And I multiply the denominator over to the other side. I expand it, FOIL it, combine my like terms, make it all equal to 0. And in this case I happen to get something that factors fairly nicely. I get x minus 5 times x plus 1 equals 0. So two answers for x equals 5, or x equals negative 1. What does that mean? It means that on these tangent lines, one of them is happening at negative 1, one of them is happening at positive 5 on that graph up above. I need to draw a little bit bigger graph. If we want equations of lines, remember, equations of lines we can give in the form y equals mx plus b. We can find the slope. If something is going to go through x equals 5 and I want to know the slope of this one is going to be the value of the derivative, so 2 minus 2 times 5. So it equals 2 minus 10, which is negative 8. So one of my equations is going to be y equals negative 8x plus b. I need to figure out a point on the graph at that spot there. Or I could use the point 2, 9, which is probably less work, since it has to go through that point as well. 9 equals negative 8 times 2 plus b. So 16 plus 9b equals 25. So my equation there is y equals negative 8x plus 25. And so you have one of your equations of your tangent lines. The other one I do the same thing, except I say, well, if x equals -1, what's the slope going to be? So 2 minus 2 times -1 means 2 plus 2, which means the slope is 4. So I'm going to have y equals 4x plus b. Again, it has to go through 2 9, so the fastest way to deal with b is 9 equals 4 times 2 plus b. So b equals 1. So my other tangent line here is y equals 4x plus 1. And if you cheat and go back to graphing calculator world and graph that original parabola, and then graph these two lines here, you'll find that they both are tangent to the curve at their respective points, x equals 5 and x equals -1, and they also both go through the point 2, 9, happens to be where they intersect. Very complicated example, lots of work, but definitely something that puts it all together.